All right, so let's do this. So this test starts with confidence interval stuff. Right? So you have 3 confidence interval formulas, and then the 2 N formulas. Right? So, when will you use one of these 3? When I ask you. When I ask you to create a confidence interval. That's it. So if I'm not asking you to create a confidence interval, you should not use one of these 3. I always get somebody that uses one of these in the middle of a hypothesis test. No, it's got no place there. I'm not asking for a confidence interval. It's a separate thing. When do you use these formulas here? When I'm asking you for what?
How many more?
Yeah, and it is sample size. So if I ask you how many more, or how many do I need to look to be within so much, that's one of these formulas. If you don't know P hat and Q hat, you assume that they are 50-50, yeah. That's actually what makes N the biggest it could be. If there's ever something we don't know, we kind of penalize ourselves for it. Right? It's just the same way if it's something you don't know, I penalize you for it. So that's all about confidence intervals. I like it. And then we move into hypothesis tests, and there's really not that many new formulas in it. So if you want to, you can put a little Z star. You can put a little sigma X bar. You can even put, just to remind yourself, even if it's S, you still have to do this to it, right? When you divide by square root of n, you're not creating a sample standard deviation. You are creating a standard deviation for a group of n things. So I don't care, I love it when somebody says, it's already S. That phrase makes no sense. S is for individuals. You need the one that works for groups of n. No matter if it's sigma or S, I don't give a shit. They're both individual spreads. I need the spread for groups of size n. How we doing? You guys okay? You guys okay? It's only a few weeks left. Can you believe this shit? Thanksgiving's right around the corner. My God. Christmas decorations have only been up for like 3 months. You know? Let's see. Now we get to the real new stuff. What is... I love random chairs. You remember how we stole this from this? We said, we already did some work over here. Let's just use that. That's the spread. So there. Why aren't they having hats on them? Because what's a hat on the P and Q mean? It's a sample. And if I know P and Q for the population, of course I use that. Same way, of course you use sigma and not S if you knew sigma. Here, I don't know what P and Q are. That's why I have to use P hat and Q hat. There, I'm assuming I know what P is. So I'm not going to use P hat and Q hat. Okay, maybe. Okay. Let me see. Am I leaving something out? I guess here this would be T star, but they both measure the same thing. That's why I kind of use them interchangeably. Let's see. Am I missing something? You guys? By the way, chapter 10 is not on this. We didn't make it into chapter 10. So we'll talk about that after this test. You guys with me? Chapter 10 is for 2 samples. Yikes. Did I forget anything? I can't. Let me think. I don't think so. Of course, I'm the guy doing this, so I could be wrong. Is there anything else that you want to be able to have on your formula sheet? I know the answer to that is yes, but anything you think you should be able to have on your formula sheet? Okay, all right. Okay, so that's that. You can bring in all your other formula sheets. Maybe not the ones you lost points on. Maybe rewrite those. Okay. So now, I did email you the practice test. All right, so that's why I thought, why do so many people need this? Because I only printed out a few. Yes. Yes, yes. Yeah, that'd be so mean. These you can't use them. No, this is on your formula sheet. You bring it with you. I like it. I'll let you guys think for a minute. Everybody got theirs back? Your quiz? All right. Sir. No, the higher one first. So it was curved. The grade in black ink is the curved grade. That's your grade. The other one doesn't exist anymore. Okay, so now it's wide open. If you want to talk about something from the quiz, if you want to sit there and work on quiz corrections until you hear a question that you want to listen to. Homework problems. I haven't really gotten much homework from you guys, which is troubling. For you. Yeah, it troubles me too. Or just general ideas. Do these spur any questions? Do these look familiar, hopefully? What questions do you have? If you have a question, I guarantee at least 12 other people have that question. You can be their hero for speaking up, if just for one day. No, you guys don't like the songs. Yes? Oh, I emailed it out. I gave out all the copies I brought. I forgot I didn't print it out last time, but I emailed it out. I told you I would. Checking email is a good thing. Second, I have the answers with me. I'll give it to you eventually. Maybe I should start tweeting things. It's fake data.
I don't have anything else.
I didn't print it out because
We can just bring up the picture of it. Oh yeah, that just looks so good. I like that.
Yes. Six? Oh, 6 is the one that's from chapter 10, so that's not going to be on this test. Yeah. Say again? Yes. It won't be on this next test, but we will discuss it after this test. Yes? Oh, so everybody got this here? Yeah? And it's on the video too. Okay.
Oh, wait.
I just said, has everybody got this? It pays to pay attention. Okay. So what's the magic word for figuring out what goes here? Yes. Will it always be that word? No, but a lot of the time it will be within, because that's the idea. This is how much you're off by. So tell me what it is within a couple feet. Within. So within is a natural word to use for this. So if I say within 7%, what will E be? 0.07, good. Not 0.7, not 7. 7% is not a number. It's a percentage. What's the number? 0.07. I like it. So that was one of the bigger mistakes made on that one. Do I have to make P hat and Q hat 0.5 on that problem? No, it's 2C. I already know what P hat and Q hat are. Calculated them before that problem, right? So you should know what P hat and Q hat are. You already calculated what Z is. And you know what E is. Whatever is 3%, 4%, whatever is said for your quiz. Is that decent? I mean, then it's just throw things in there. So if you figured out Z was 1.96 and you figured out P hat's 0.75, 0.25, you just throw it all in there and calculate it. So, a lot of people were squaring these bad boys, and there's no squares on those. I like it. Yes?
Can we go over just like the concept of the Z star?
Can anybody? So that's something I made up myself, totally
No,
made
I
up
know
myself.
that,
No, I'm just, why is there a star in that? What's it about hypothesis tests? I have 2 Z scores in a hypothesis test, right? One of them comes from alpha. And that tells me what far enough away is, right? So maybe it's 1.96. And the other one, of course, comes from my sample. And that's Z star. And that tells me how far away my sample got. Right? So if I'm trying to recruit a quarterback and I need somebody who's got a strong arm, I might say, well, you have to get it at least, you have to throw the ball at least this far. And then so evidence they should be on the team would be getting past that. Evidence against them being on the team would get before that. Do you see that? That's a benchmark to reach. So if I do a Z star for a sample and it gets there, that's evidence that something is different. That's evidence that the null is wrong, because the null thinks it's in the middle here somewhere. So I don't know on what level. That's a very high level of just like discussing the idea. Did you want to drill down further or no? Okay. Yes?
When you're choosing where your rejection level is going to be, you're always looking at the greater than or equal or like less than, like the
H1 always sets up where the rejection region is. The first thing you worry about is a claim, and then you forget it. Right? The claim does not set up your rejection region. H1 does. So if the claim was, let's say that there's a claim that the mean is at least 11. Where would that go? Why here? Because it has an equal sign in it. So what goes into H1? So how many tail test? Where's the tail? I kind of give it away. Didn't I? How many tails? And where is that one tail? One tail. And where is it? Yeah, H1 always tells me. Why? Because I can show evidence that it's different. I can't show evidence that it equals something. But I can't show evidence that it's different. If I take a sample and I get an average of 10, does that mean the population average is 10? No. I almost bet money that it isn't. It's almost proof that it isn't 10, to be honest. But if I get a sample, I take an average of 10, and somebody else thought the average was 20, maybe that's evidence that it's less than that.
And does it always go in the order like reject, HO?
Yes, you can only ever reject or fail to reject the HO. You can only ever support or fail to support the H1. I like it. Do they use that language in the real world? No, but the idea behind them is used in the real world. And we can do example problems. We can do what we're doing right now, examining ideas. I love it. We can get really detailed or just talk about general ideas. And you're like, wow, that's how classes work, Jeff. Yes? Yes?
In question 3, you gave us data and we make L1. So when we can calculate it, calculator, so we have the S and S. So why we always choose the S?
We don't always, but what is it in number 3? What kind of data do I have? Is it population data or is it sample data? There you go. So then you have to use what? S. Why does a calculator give sigma and S? It's just a stupid calculator. They are stupid, right? They can do a lot of shit, but they're dumb. They can't tell. They're like, here, pick one. And we're the humans. We go, oh, excuse me, calculator. It's this.
So for number 3, we would calculate in the calculator and use S.
S, you have to. There's no choice to make. You can't say, but I know sigma. No, you don't. That would be sigma if it was a population you put in. You know you put a sample in, so you know that S is the real thing. Sigma is not true. The cake is a lie. Oh, man. So many references over here. Yes?
Could you go over section 9.5 one more, question number 74, I?
Wow.
Find the confidence interval for the
Can you be more specific? Let me see. Which one? 74?
74,
I. I. Oh, now please tell me I said this. It's possible I didn't. The book, I'm pretty sure I said this. The book has its own little sheet. You screw that sheet. You do the steps. It's the same steps. They just do it out of order because they use the calculator way too much. Right? And you can say, well, no, Jeff, you don't use it enough. I don't give a shit. I'm the teacher, man. Right? So don't use their sheet. Use our 5 steps. Same steps, just out of order for them. So what do you mean I? What's I?
I was asking you to look at the confidence interval.
And am I in the right place? Chapter 9, right? 74. Is that on the stupid sheet? Oh, that is on the stupid sheet. No, I don't need you to do that. Yeah. I don't need you to make a confidence interval. Right? That's one reason why I said don't use the sheet. This is not for confidence intervals, this is a hypothesis. So yeah, it's a free book. I didn't write it, so it's not going to match what I want exactly. It really sucks when you pay $180 for a book and then the teacher's like, well, forget about this. At least it's free. Yes?
Question number 4, I just wanted to be sure about the claim. I know he will give us the answer, but I just want to know how
4?
to put the claim, yeah.
So what's in English, what's the claim? A new drug is developed that brings relief in less time than the old one.
So that's going to be the E.
So it says it brings relief in less time than the old one. How long did the old one take?
16 minutes.
16.1, there you go. So there's the claim. And then you can tell if it's going to be HO or H1.
So here we will not put equal, only.
Yeah, it says less time. So it's strictly less.
So that goes to H1.
H1, I love it. So H1 would be this. And what's HO? And then you forget about the claim. How do you set up your rejection region eventually? Using H1. Whatever, in this case it happens to be the claim, you don't care. The claim gets us started, we forget about it. And then we bring it back in at the end. The middle is where we're doing the work. The claim's just got to sit there and wait. All right. Yes?
For the practice test, number 1 for B, it says how many more students would you need to survey to be within 1/2 hour? How would you just be 30 or 0.30?
No, come on, no. All right. I love you guys so much. 30 minutes. Is that 30 out of 100 minutes? Yeah, 30 minutes is half an hour, which is 0.5.
That's all you do?
Yeah. So I don't mean to... That's something that a lot of students don't have a grasp of, is how decimals are created using percentages of time and stuff. So I see this a lot. There was something where it was I talked to 106 people and 75 of them said yes. So too many people said that p hat was 75%, 0.75. No, it wasn't 75 out of 100. It's 75 out of 106. You better calculate that shit, right? So yes, a percentage does mean out of 100. So if there were 100 things and X of them did something, then you got X percent. But if it ain't 100 things, you basically have to reduce it down to 100. How do you do that? You divide. So it's not entirely your fault. So if I seem angry sometimes that you don't understand something, I'm angry at the system that brought you here. Right? Very often high school is sucking nowadays with math, and they seem to be saying college can fix all the ills. I'm like, I like to think I'm a great teacher, but my God, I can't fix 12 years of shit. All right, sorry. I feel ranty today. Sorry. You're like, you feel ranty all the damn time, Joe. Yes. There's a lot of crap going on, so I feel ranty all the time. Yes?
When do you notice that you're gonna fail to reflect, when you're gonna when you word?
All right, so here you go. Here, you ready? Okay. If this is my rejection region, right? And I got HO and H1 up here, step 1. Oh, and I get a sample right there. Did I succeed or fail? Failed. Does fail always mean a bad thing? No. If I'm like, I think it's 7, let me try to show it's not 7. I failed. I'm happy. I thought it was 7. I want to fail if I'm trying to show it's not 7. This is the thing about science. We're like, I think it's this. Let's test if it's not that. That's what science does all the time. Did that test say no? No. Good. Did that test say no? No. Okay. Did that test say no? Yes. Ah, shit. And then we're happy because we're like, anything's great. Any results? Oh, sorry. Again, ranty today. Sorry. If I get there, I failed. So what did I fail to do? What? Fail to reject the hope. Fail to support the high. If you don't get in there, you failed. So you failed at this, which also means you failed at this. These both say the same thing. If I can't say this guy's wrong, I can't say the other guy's right. So I just wrote the same thing twice. But the words do matter. Which one do I pick? Well, it depends on what the claim was. If the claim was HO, then I will use this language. That's all there is to it. Somebody makes a claim, and you test it. How should your answer to them be worded? You should talk about the claim. They want to know, was my claim right or wrong? Well, the opposite of your claim looks... No. What my claim? Talk about my freaking claim. Doesn't that make sense at the end? Maybe. I mean, there's no ambiguity there at all. You don't just guess. You see, what was my claim? And then you pick the wording based on what your claim is. So we have not found sufficient evidence to reject the claim that blah, blah, blah. If the claim is H1, I would fail to support it. So if our claim is HO, if we think it's somewhere in here, and our sample ends up somewhere in there, then you didn't reject my claim. Nah. My claim looks okay so far. Maybe. So I don't know if I told you, that's my hopeful Tai Chi. Yes? 4E? So the conclusion. So what did you find on 4D? Oh, yeah. Okay. What does alpha set up? What is alpha set up? the rejection region, right? So if alpha changes, then this number is going to change. My benchmark is going to change. That's like the coach saying, all right, no, I want to actually make the benchmark there. You got to throw the football farther. I want some Hail Mary shit for the end of the game, right? This guy can't even get it to the freaking goal line. It's just maybe. So on that one, you just figure out what would the rejection region become. Now, on that particular problem, it actually wouldn't change at all, because the Z-star is big enough to just pass both of them, if I remember correctly. But in general, if I used a different alpha in some of these problems, it would totally change. So if I got a Z-star of 2, then that would work, right? I would succeed. But what if my alpha made it 2.326? And my Z-star is 2, would I succeed? No, I would have failed. So I really want you to understand this. Let me see. You guys help me out real quick. Ready? So let's say we have a 1.96. That would be an alpha of, give me a second. It shouldn't take me this long. 0.025, I think. Double check. Has anybody got their T-chart right there?
Yeah.
All right. So let's say I get a Z-star of 2. Can somebody tell me what the p-value would be? If a Z-star was 2, what's the p-value? So what's alpha? Alpha is the area of the tail of the rejection region Z-score, right? What's the p-value? It's the area of the tail of my Z-score. So what's in the area of the tail of Z equals 2? Look it up on your Z-score chart. I love you guys. You're all just sitting around like somebody's going to do it. Do I have a Z-score chart? Yes. I know it. You could do it.
It's 0.9.
Yeah, so you get 0.9772, but that's this area. 1 minus that would be 0.0228. Do you see how that's less than this? Because it's further, so of course its tail is smaller, isn't it?
But that is because we're looking at greater than.
Always looking at the
If it
tail.
would be, yeah,
If it was down here, I would have just looked up and been done with it. But I always got to get the area of the tail. So, if I made my Z-star, my critical region 2.326, that would be an alpha of 0.01. I would not have succeeded, right? Does 2 get into this? No. And see how alpha is 0.01 makes it harder to pass. Alpha 0.025, I passed it. Look, 228 is less than 25, right? But it's not strong enough to pass this test. This test would be more significant of a test to pass. Oh shit, that's why we call it level of significance. In real life, there are no alphas written anywhere. So why do we use them in here? Because we don't know real life yet. We got to have some kind of a benchmark. But in real life, if you get into a place where you're using these things to make decisions, you create your own alpha based on what's good enough evidence for you. That's why you find p-values all the time on journals. So that you can say, so 0.0228 might be good for some people, but not good enough for other people. So in general, you would say that's a decent result, but it might not be good enough for some people. They're like, well, you should redo that test and see if you get a lower p-value. This is this whole idea of science having to be repeatable. If one group does this and another group gets something way over here, they didn't verify their findings, right? That's why we support, not accept. Because somebody else the next day might not support it, right? So it's not proof, it's support for it. So I know some of you guys are like, stop talking about the idea, just tell me what the hell to do. That's not the purpose of a freaking class. And nowadays it just seems more and more like you want to strip down. It's too bad you took the wrong guy for that shit. The more you understand the idea, the easier the work is. Because then it's less memorization and more just doing what makes sense. That's why some people can do a lot of math and some people can't. Because these guys just think everything's memorization. Oh my God, you ain't got enough room in your brain to memorize everything. Good Lord. All right, sorry. Ranty. Sorry. You guys want to, we can do a specific problem if you want. I can, pretty good at creating examples. Yeah, practice test. See, I made all those examples. It's not even 8 o'clock yet. Jeez. So let me, yes, Joseph. No, you got a question? Okay. No one's asked this question yet, so I'm going to ask it for you. Jeff, what are type 1 and type 2 errors? Well, that's a good question. You must be doing the homework. Or, trying the practice test. So, the thing about statistics that some people can't get over is the fact that built into it is an allowance that you could be wrong. And to me, it's kind of dumb for people to expect there to be anything other than that, because that's just freaking life. But it doesn't mean you did something wrong in the problem. It's just built in that you're testing things based on a sample. And what could happen with a sample? You could arbitrarily pick people that are older than average, or you could arbitrarily pick nothing but the lowest grades, right? You could just randomly pick that. That could happen. So what are the two things that could happen as a result of a hypothesis test? There's really only two things. You can reject the null, which means support the high. That's one thing. That's one thing, right? You can reject the null, which means support the high. Or you could fail to reject the null, right? Which means you failed to support the high. And those are the same thing. So one thing that could happen is reject the null. When would that be the wrong thing to do? If the null was actually correct. Okay, so one type of error, the type 1 error, is when you reject a true null. Ooh, it's all squeaky now. So, and do you see how, so for example, I've set up a rejection region. This is, let's say the alpha is 0.05, and I get a z star that's in there. I'm going to reject the null. What's the probability? So again, I really desperately wish you could all understand. Assuming the mean is here, I just did something really unlikely. So what's more likely is the mean is supposed to be up a little bit. If the mean was up a little bit, wouldn't this be more likely then? That's the whole idea. Is there a chance I'm wrong? Yeah, there's a 5% chance that something will show up here even if the mean is in the right place. So 5% chance of being wrong is pretty good, right? If I had a 95% chance of surviving some big surgery, that's pretty good. Only a 5% chance that the doc's wrong. You guys with me? Okay. So to be honest, what's really funny is that I can control this error's likelihood. The smaller I make alpha, the less chance there is for me to make this error. But it kind of makes sense. The smaller I make this error's probability, the bigger the other error's probability gets. What's the other error then? Well, what's the other thing that could happen? The null could actually be wrong, but I fail to see that it's wrong. So the other error, remarkably enough, we call it type 2. Ooh. So the other error would be fail to reject. Oh my God, it's crazy. A true. No. I'm sorry. A false. No. Sounds biblical in a way. I'm not religious about it. So you must reject the true null. All right. So if the null is false, but we fail to reject it, that's a problem. So that would be that same situation. Here's my rejection region, and I get a Z star there. Couldn't the mean actually be bigger? But we didn't show evidence. We failed to reject that the mean's in the right place. So we didn't show it. So that the bigger this gets, the smaller this error, this probability gets, and vice versa. So let's do an example. I like to do a non-math example, right? Some of you guys don't think that I can do that. So let's say I'm a battlefield medic. You guys with me? There's a war going on. I'm out there running around, checking people. What am I doing when I'm coming up to somebody? What do I do when I come down, somebody's laying on the ground? Check to see if they're alive. I like it. So let's see if you guys can help me. What would be my null? What would be my claim? Or let's see, how can we put this together? My claim should probably be that they're alive. That's why if my claim was they're dead, why would I waste time going to them, right? So it's up to you really which one we put that in. Let's say this is they're dead. So the H1 would be they are alive. So I come up to them and try to show evidence that they're alive. See if there's a pulse, check the breathing, whatever. Slap them on the face. Okay. So now let's think about it. What, in terms of the errors, the type 1 error, what's the reality for the type 1 error? What's the reality? They are
Dead.
So they are dead. What do I think? I reject that. I think that they are alive. Maybe I use my thumb because I'm a horrible medic. You guys understand, if you use your thumb, what are you feeling? Your own pulse.
Yeah.
That's why you never use your thumb to check pulse.
Yeah.
So I feel my own pulse, right? I'm like, oh my God, they're alive. So I've made a mistake. What would be wrong with that mistake? Why would that be a bad mistake to make? True, but what probably is true besides this one person? There are probably other people. Maybe some of them are actually alive, so I am wasting time. I should be helping them. So there's an error I made, and how bad that error is really actually determines where we set alpha to be. So that's the whole thing I've been talking about forever about the nuclear power plant. I would set my alpha to be really high so that I get my ass earlier. The minute it starts to go to the yellow, I'm up, right? I'm not like, just wait till it gets like right in the red a little bit. No. So what about a type 2 error? What's true? What's really true? The null would be false. So they're actually alive. But I think they're dead. Now that obviously would suck. Especially for me laying on the ground. You come over, check out, I'm like, thank God, I can't move, but thank God somebody's here. And then they walk, and then they go away. I'm like, screw you. So that would obviously be bad. Oh my, this is a little morbid, I know, but still. I like this as an example, because you can see the relative, the outcome of making these type of errors. You can see how they would be a little bit different. Now both of those are kind of like this, similar levels of bad, right? But still, you guys see what I'm saying here? Those are the types of errors, and the fact that nobody asked me about them has me worried about where you are in the homework, because that happens, I think, early. I think it's in section 9 too, which is, or maybe you read it and you understood it. I can always hope for that. Some of you guys are like, I haven't done chapter 9 more. All right. That's your choice. You always have the option to fail. Okay. All right, so that's types of errors. So on the practice test is number 7? 7. Yeah. Yeah, there is, isn't there?
No.
Oh, did I? Don't even tell me I sent you out a different copy. Let me see yours. Oh, so you don't have, oh good. So you have a better thing actually. I like it. Okay, good. So I didn't ask the question about doing a hypothesis test. Okay. I had a different version of the practice I think that I used, so that's better. This is better. So there is no chapter 10 on this practice test. Good. So when you get the answer key, ignore number 6. Number 7 is your number 6 in the answer key. All right. Maybe I change that before I send it to you. It's possible. All right. So, for example, if your null was p greater than or equal to 0.1, what would the type 1 error be? The type 1 error would be the percentage is actually at least 0.1, but we think it's less than 0.1. It's that simple. Type 1 error is the null is true, but we don't think so. So percentage is actually at least 10%, but we think it's less. That's all there is to it. There's always a chance we're wrong. Not just because you made a mistake in your work, but because it's built in. It's real freaking life. Real talk, guys. Okay. I think. Is there something else you're not asking you should be? Oh, did we finish that? Let's do this. This is probably good. You guys need an example and nobody's asking for one. Here's one that we can do. This is that. The back of that has got the Occupy Wall Street stuff on the front. Let's see if I have. Anybody need a copy of that? That I have copies of. Yeah. New payment, no, survey of 322. It says in a survey of 322 college staff professors. That's the problem. Oh, I should have worn these guys. Give me no trouble this whole semester. Okay, all right. Where did I steal this from? Oh, interesting. Okay. Me too. Okay. So I think we obviously, got to this point. How do we know it's two-tail? Yeah, it's got the not equal to in the H1. And how do you show something's not equal to? It's bigger or less. So either side would be evidence. So when you don't see a directional word in the problem, like less than, we think it's increased, we think it's gone down. Do you see what I mean by directional word? More than likely, it's a two-tailed test. We feel it's 7. Okay, it is 7, equals 7. The opposite would be not equal to. See how it's hidden? It's very easily missable. Okay. So here we think it's the same as, so the opposite's not equal to, it's a two-tailed test. Can we use z-scores? What do I have to check?
NP and Q.
Yeah, I don't have any freaking standard deviation. I don't need any standard deviation. We're going to create it later. What kind of problem is this? It's a percentage problem. And what do I check for percentage problems? NP and NQ. What's N? Say again? 322. And what's P? 845. So that's definitely bigger than 5, whatever the hell it is. Say again? 272 roughly. It's at least 5. And then 322 times what? 155. And that would be 50 about. How'd I do that so fast? These have to add up to 322. All right, how are we doing so far? So n being greater than 30 doesn't mean shit for these problems. It's got to be NP and NQ. I check because it's a percentage problem. What do I need to know to be able to do this? I already know it's two tails. Let me get some more paper. Go right through this thing. Oof. It's two tails. What else do I need to know? We got z-scores. What do I do if one of these is less than 5?
It's not normal.
Not normal, can't do shit. So you never use t-scores for these. It's only z or nothing. How many confidence interval formulas are there for p hat? 1. It's only got z in it. There's a note. You never use t-scores with p problems, with percentage problems. They weren't invented for that. How do I figure out what these are? What's alpha? 0.10. It's a two-tailed test, and it's z-scores. Can somebody tell me what that would be?
Negative 1.645.
Yeah. 1.645, I like it. Everybody able to find that? That actually wants to get ready for the test? Yes? So if you look at the t-score chart, two-tail 0.10, go all the way to the bottom, you should see 1.645. So what do I put here in words? If z star is
Not equal to.
no.
Less than negative 1.
If it's less than negative 1.645 or greater than 1.645, we can do what?
We can reject the null.
Yeah, why does that make sense? Because I would be in the rejection region then. What an awesome name. A region, if you get into it, you reject something. Hey, math people finally made something right. Reject the null, which also means support the high. So if we don't get in there, we fail those things. Now, I'm not going to do this for you on the test. It's just very nice here. What's n again? We already know it's 322. What's x? 262. So then 262 out of 322. Now, dear God, if you get p hat equals 1.28, you stop. You say, okay, did I just put things the wrong way? You don't keep going. No, that makes me cry. You see little drops in your test. Sometimes it's coffee, sometimes it's tears. What is 262 divided by 30 times 10? Who is it? 814? Okay. So you guys try to finish this part out. Figure out what Z star is. What are you guys getting? Anybody? Woohoo! Now here's the freaky thing. All right. I can't remember if I talked much about this yet or not. When you go to find the p-value, does this make sense? You find the area and the tail of that, but then you double it. Why? Because this is a two-tailed test. Alpha is split across two tails. So to really be able to compare it, you got to double what you get in the area of that. So when you look at negative 1.54, what do you get for the area and the tail of that? What's your